Hi, welcome back to Math with me, Marisol Lopez, your second grade math virtual content specialist. Think of me as your teacher's helper. In this video, we will be continuing our learning about line plots. All right, let's get started. Today, we will be answering the following question. How can you represent a data set and draw conclusions? In this video, we will be using data from line plot graphs to help us answer questions about line plots as well as solve problems involving line plots. In the past, we have learned about the following graphs: tally charts, bar graphs, and picture graphs. In our previous video, we started learning about line plots. Line plots show the number of times that something occurred. For example, in this line plot titled Class Pets, it has the number of pets along the bottom, and above each number, it has a number of X's. This means that there were 5 students in the class who had 1 pet, 2 students in the class had 2 pets, 7 students in the class had 3 pets, 1 student in the class has 4 pets, 3 students in the class have 5 pets, and 2 students in the class have 6 pets. Overall, we learned that graphs are used to organize information or data in a way that is easy for others to understand and analyze. Today, we will continue learning about line plots by using the information displayed to solve word problems and answer questions. Let's look at an example from today's lesson. Read the instructions with me. The students in Mr. Shield's science class are growing bean plants. After 5 days, they measured the height of their bean plants in centimeters. The table shows their results. Height of bean plant, number of students. 9 centimeters, 1 student. 11 centimeters, 4 students. 12 centimeters, 6 students. 13 centimeters, 7 students. 14 centimeters, 5 students. 15 centimeters, 3 students. And we have the line plot over here. It says bean plant height in centimeters. What information can you see in the line plot? Well, to answer the question in the blue box, the information in the line plot is displaying the data shown in the chart on the left. I am also noticing these 2 little hash marks, which means that there is no data between 0 and 9. And when I look at the data table, it is true. The data starts from 9 centimeters. So the line plot is displaying the information in the chart. We can see here 9 centimeters has 1 student, just like in the table. 11 centimeters has 4, and 10 is left blank, right? There were no bean plants that had 10 centimeters of height. Let's look at another example from today's lesson. Read the instructions with me. The chart shows the heights of second grade students in Mr. Yin's homeroom. Use the data in the table and the line plot to answer the questions. Height of second grade students, number of students. 40 inches, 1. 41 inches, 2. 42 inches, 2. 43 inches, 3. 44 inches, 4. 45 inches, 4. 46 inches, 3. 47 inches, 2. 48 inches, 1. Again, going to the line plot, the title is Heights of Second Grade Students. It seems like they took the data from this table and put it in the line plot. I am noticing the 2 little hash marks between 0 and 40, which means there is no data between 0 and 40 inches. And that is also true in the table. Starts from 40 inches. What is the difference between the tallest student and the shortest student? The question in the blue box is a comparison question. And because it says difference, our mind should already be thinking subtraction. Let's look at the line plot. The tallest student is 48 inches tall. The shortest student is 40 inches tall. An equation we can write for this is 48 minus 40 equals 8. Let's look at another example from today's lesson. The chart shows the length of paper second grade students used in their art projects. Use the data in the table and line plot to answer the questions. Length of paper, number of students, 3 feet, 2 students, 4 feet, 11 students, 5 feet, 9 students, 6 feet, 6 students. Again, they took this data and they put it into the line plot. They're asking us how many art projects were made. Well, in order to find out the answer to this question, we have to add up the total of our projects made, which is illustrated by the number of X's on the line plot. 3 feet of paper was used by 2 students. 4 feet of paper was used by 11 students, and so on. An equation to represent what is happening in the line plot could look like this. 2 plus 11 plus 9 plus 6. Now remember, in addition, we can add the addends in any order and still get the same sum. That is called commutative property. Let's see, if I add together the 11 and the 9, I know that that gives me 20. Then I am left with 2 and 6, which I know that 2 and 6 is equal to 8. Therefore, 20 plus 8 equals 28, and that is our total. We can write that as a sentence to answer the question, 28 art projects were made. For the last question, what paper length occurred most often? We can already see that by looking at the line plot. 4 feet has the most amount of X's, and also in the data table, 11 is the largest number. Therefore, 4 feet of art paper occurred most often. You learned a lot about line plots today. I am sure you will become more comfortable as you keep analyzing more and more line plots. Great work today, mathematician. Until next time, bye-bye.